In this video, we are going to discuss few problems on Cauchy's derivative formula. First problem is, using Cauchy's integral formula, evaluate integral over c e to the power 2z by z plus 1 whole power 4 dz, where c is the circle, modulus of z is equal to 2. In step 1, find the singular point. The given problem is integral over c e power 2z by z plus 1 whole power 4 into dz. In step 1, in the as usual way, we are going to find the singular point by equating the denominator value to 0. Z plus 1 whole power 4 equal to 0, therefore z is equal to minus 1. Therefore, the singular point is z is equal to minus 1. And then draw the diagram for the given image. Given image is modulus of z is equal to 2. Substitute here z is equal to x plus iy, and then remove this modulus. Root of x square plus y square is equal to 2. Squaring on both sides, get x square plus y square is equal to 2 square. We are getting one circle equation. The center of the circle is 0, 0 and radius will be 2. We know that the general equation of circle, which is x minus a whole square plus y minus b whole square is equal to r square. Here a and b are 0 and radius r is 2. And then we can draw the diagram. X axis, y axis, center 0, 0 and radius 2. Still this. This is the given image diagram. Okay. Step 1, find the singular points. Step 2, draw the diagram for the given circle. Then now here z is equal to minus 1 is lies inside the image modulus of z is equal to 2. See here z is equal to minus 1. Z is equal to minus 1 means minus 1 plus I0. The point is minus 1 comma 0. Minus 1 comma 0 means here will come. Obviously here z is equal to minus 1 lies inside the given image. In this case we can use Cauchy integral formula. In case if it is lies outside the given image means using Cauchy integral theorem, we can write directly integral over c f of z dz equal to 0. But in this problem, the singular point is lies inside the given image. In this case, we can use the Cauchy integral formula. Okay. If you want to use Cauchy integral formula, see, look at the power value here. Here power value is 4. If the power value is 1 means we can use the Cauchy integral formula. Power value, if the power value is more than 1 means we have to use the Cauchy derivative formula. Here power value is 4. In this problem we are going to use the Cauchy derivative integral formula. Derivative integral formula. Integral over c f of z by z minus a whole power n plus 1 into dz equal to 2 pi I divided by n factorial into f power n of a. You should remember this nth order formula. Then only we can easily write the formula for any order. Okay, in this problem power value is 4. 4 means you just compare with the formula. In the formula power value is n plus 1, which means here n is 3. N is equal to 3. In this general formula, nth derivative formula, substitute n is equal to 3. If you put n is equal to 3 in this formula, we will get the third order derivative formula. Integral over c f of z by z minus a whole power 4 dz is equal to 2 pi I by n factorial. What is n here? N is 3. 3 factorial f power n third derivative of a, which is the required third derivative, Cauchy's third derivative integral formula. Okay. Now, what is the right here? What is our given f of z? E to the power 2z numerator term. In the denominator term, we are having z plus 1 whole power 4 into dz equal to, you just compare with this formula. Now we can write 2 pi a divided by 3 factorial. The value of 3 factorial is 6 into f triple dash of a. What is a here? A is nothing but singular point, minus 1. Now we are going to calculate the value of f triple dash of minus 1 value. This becomes pi I by 3 into f triple dash of minus 1. Now we need to calculate f triple dash of minus 1 value. From the given f of z, we can easily calculate. What is our given f of z? F of z is nothing but our given numerator term. Compare with the formula e to the power 2z. Okay. From this, tell me what is f dash of z? F dash of z is first differentiation with respect to z. E power 2z into 2. F double dash of z is e power 2z into 2. Already we are having here 2, which is 4. Here substitute z is equal to minus 1. E power minus 2 into 4. F triple dash of minus 1 value is e power. We need to calculate f triple dash. Calculate f triple dash. Once again differentiate with respect to z, which is e power 2z into 2 will come. Already we are having here 1 4, which is 8. Now substitute here z is equal to minus 1, which is 8 into e power minus 2. Okay, substitute here the value of f triple dash of minus 1 here, which is 8 into e power minus 2. Therefore, is equal to, we can write 8 by 3 pi I into e power minus 2. That's all. Next problem. Evaluate. Integral over c z into e power 2z by z minus 1 whole cube into dz, where c is the circle, modulus of z plus I equal to 2. Okay. In the as usual way, in step 1, find the singular point by equating the denominator value to 0. The given problem is z into e power 2z by z minus 1 whole cube into dz. Z minus 1 whole cube equal to 0. Therefore, z is equal to 1. Here the singular point is z is equal to 1. And then draw the diagram for the given region. Modulus of z plus I equal to 2. Here substitute z is equal to x plus iy plus I equal to 2. And then write separately real and imaginary terms. Here I common from the second and third term, which is I into y plus 1 equal to 2. Now remove this modulus. Root of x square plus y plus 1 whole squared is equal to 2. Squaring on both sides, we are getting x square plus y plus 1 whole squared equal to 2 square. Okay. The center of the circle is, we know that the general equation of a circle, which is x minus a whole square plus y minus b whole squared is equal to r square. From this we can write center of the circle is 0 comma minus 1 and radius will be 2. Okay, now we can draw the diagram. x-axis, y-axis. Center is 0, comma minus 1. X value 0, y value minus 1. Here. Radius 2. Which means we have to take, first you split like this. 1, 2, minus 1, minus 2 likewise. 0, comma minus 1 is here. Radius 2 means till here. This side till this side. Till here. This side till here. Draw the circle now. Okay. Now we are going to check with the singular point. The singular point is here. Z is equal to 1. The radius is here 2. Which means here Z is equal to 1 means 1 plus 0i. The point will be 1 comma 0. X value 1, y value 0, which is here 1 comma 0. Z is equal to 1 lies inside the given image. The singular point Z is equal to 1 is lies inside the circle modulus of Z plus I equal to 2. Okay. In this case, we can use the Cauchy derivative formula. Why we are going to use here Cauchy derivative formula means here power value is 3. If the power value is 3 means in the denominator term, which means if the power value is more than 1 means we have to use the Cauchy derivative formula. First you write the nth derivative formula. Nth derivative formula is Cauchy's derivative formula, integral over c f of z by z minus a whole power n plus 1 into dz is equal to 2 pi a by n factorial into f power n of a. Okay, you should remember this formula, then only we can easily solve the problem. Okay. In the given question, check the denominator term. In the denominator term, power value is 3. You just compare with this formula. Power value 3 means 3 is equal to n plus 1. Therefore, n is equal to 2. In this general formula, nth derivative formula, substitute n is equal to 2. Getting f of z by z minus a whole cube dz is equal to 2 pi a by 2 factorial into f power 2 of a. This is the second derivative formula. Okay. Now we can write integral over c z into e power minus 2z by z minus 1 whole cube dz is equal to 2 pi I divided by 2 factorial is nothing but 2 f power double dash of a. What is a here? Singular point. Singular point a is 1. Substitute here 1. Now we need to calculate the value of f double dash of 1. Okay. Here we can remove this 2. Pi I into f double dash of 1. Okay. From the given f of z, we can easily calculate f double dash of 1 value. The given f of z is z into e power minus 2z. What is the first derivative for this one? Differentiate with respect to z with the help of UV rule. Z into e power plus 2 only, not minus 2. Z into e power 2z into 2 plus e power 2z into 1. We applied here UV rule. U into V dash plus V into U dash. Once again differentiate with respect to Z. Here 2 common, 2 constant. Again apply UV rule here. Z into e power 2z into 2 plus e power 2z into 1 will come. Okay. Last term, this one separate term, which is e power 2z into 2 if you differentiate with respect to z. Therefore, f double dash of z is equal to, this 2 is common for both, taking inside 2 into 2 4, 4z into e power 2z plus 2 into e power 2z will come. Already we are having here 2 into e power 2z, which is 4 into e power 2z equal to, we can write 4 plus 4, 8 times of 8z into, sorry, f double dash of z is 4z into e power 2z plus 4 into e power 2z. From this we can easily calculate f double dash of 1 value. Substitute here z is equal to 1, 4 into 1 e power 2 plus 4 into e power 2. Therefore, 4 into e square plus 4 into e square. If we are adding these two terms, we are getting 8 into e power 2, 8 e square. Now substitute this f double dash of 1 value in this equation. Pi I into f double dash of 1 is 8 into e square. Therefore, 8 pi I into e square, which is the required solution. Z into e power minus 2z by z minus 1 whole cube into dz is equal to, we are getting 8 pi a into e square. Without integrate with respect to z, with the help of Cauchy derivative formula, we can easily find the value for this equation. That's all.